Hello, good morning. Today we are going to discuss about the single source shortest path problem, which is the solution is developed by the dijkstras. If you are considering an undirected graph like this containing number of vertices A, B, C, D, E, F, and their weights being 1, 2, 3, 3, this 6, 2, 2 and 2. Our goal is to find the minimum distance starting from any of the vertex to any other vertices which is reachable from that particular vertex. So if I start with A, let us say I want to find the single source shortest path answer from vertex A to all other vertices which are reachable from A. So in the process, what I do is I construct a table containing two columns. One is saying the vertices it has visited so far and the vertices it to be visited. So if you begin with A and I say this itself is my starting vertex, I write A and I use some two brackets and I write what is the distance and from where you have come. Because this itself is the beginning, I have not written anything here. And from what other vertices you need to visit. So it's clearly written, I have written B, C, D, E and F. They are all the vertices it has to visit. So then by looking at the graph, I see what are the edges from A to the other vertices. If you see from A to B, there is an edge of length 1 and you can reach A, you can reach B from A, that is the meaning. And similarly, C, D, E. So from A to C, there is an edge of distance 3. From A to D, there is an edge of distance 6. From A to E, there is an edge of distance 3. And you can reach from A. From A to E, F, there is no edge. Therefore, I have written some infinity here. The next round, what you do is, out of the edges, the vertices here, pick up the vertex which is of small distance. Here the smallest distance is the B having only 1. Therefore, I pick it up. And I write here B and I say B, the distance is 1 and you have reached from A. So after choosing B, the other vertices it needs to visit is C, D, E and F. Now I look for, once again, the edges from B to the other vertices. So from B to E there is an edge and from B to C there is an edge. So the only changes that may take place is only in C and D. C it is 3 and D it is. So already the value of C it is written 3A. Now see from B to C the distance is 2. So this 1 if I add 2 it becomes 3. But however there is no improvement. I mean the already distance is 3. Now if I calculate the distance from B to C also, it is 3. Therefore I keep it unchanged. There is no change in that. And similarly, from B to no other, there is no, from B to E there is an edge. But from A to B, the distance is 1, B to E it is 10. So 10 plus 1 it is 11. So level is not an improvement over this 3. Therefore there is no change in the values in this phase. And anyhow there is no edge to F. Therefore this F it is already as it is infinity and no change. Now the next vertex which I am going to consider is a C here. However, C and E both are having the same distance, but I am taking C here. Now I calculate all the vertices which are reachable from C, keeping in mind this already the distance to reach C is 3. So now what other vertices I need to visit are D, E, F. So what are the vertices which are adjacent to C? So C to B, C to A and C to D. But A, B are already, the distances are calculated. Now I am going to check what is the distance from C to D. C to D the distance is 2. But to reach 3 the distance is already 3. So 3 plus 2 is 5. So now I look at the distance here. The distance as per the earlier one is D 6A. So 5 is an improvement over 6. Therefore I write 5 here and I say I can reach from C. Then I also calculate the other distances. So as I have taken here C and E and F, they are not as it is no edge from C to D. Therefore now out of all these things, the next edge which I am going to consider is this E. So 3, because it is the smallest as it is available, so 3 and I say it is reachable from A, because as it is I have calculated. So the distance from E to D which is not visited, so D to F, the distance from E to D it is 2. So there is no improvement as it is. E to D it was, so already up to E it is 3 and it is 2, it is 5. So there is no improvement, therefore no change in this. But now from E to F there is an edge. So the distance is 3 here and it is 2. So 3 plus 2, 5. So now I have written it as 5 and E. Then the next vertex which I am going to consider is F. The consider is F. The next edge which I am going to consider is D here, 5 and this. So any one of this I can take, I will take D. So which is 5 and C. And from D to F there is no edge. Therefore don't change the value of this one. Therefore now what I have is, I take finally the F and you see no other edge is left over. This is how we have calculated all the distances from, from A to this F. All the distances have been calculated from A to F. Now if you want to see, if you want to find a path from A to D, you see from D you are able to reach from C, and coming to C you are able to reach from A. So you write DCA. D you are able to reach from C and C you are able to reach from A. Therefore from A to D the path would be ACD. However, this table itself gives you an idea. This table itself gives you an idea regarding the vertices we have used. From D to D the minimum distance is C. The minimum distance is 5, and you are able to reach D from C and come to C. C you are able to reach from A. So A is your starting point. So this is how you can calculate the minimum shortest path from a single source. This algorithm, as I stated, it is given by dijkstra. Very easy to calculate. Thank you.